Hey guys, Mrs. Traver here. We're going to do our notes on section 5.4, multiplying rational expressions. And I'm going to do kind of a lame example with you to start to illustrate a point. So say I started with 3/5 times 10/15. First thing I want to do here is try to factor top and bottom to see if I can simplify it all. So the way I would go about doing that is I'd rewrite 3/5 as a factored pair, and that's already factored. And I can rewrite 10 as 5 times 2, and I can rewrite 15 as 5 times 3. And then I can see a bunch of things can cancel. These 5s on top and bottom can cancel, and these 3s on top and bottom can cancel, so I would just have 2/5. So again, kind of lame example, but it'll illustrate what we're doing here. We're going to start with factors that aren't just regular numbers. Instead, they're going to be rational expressions. So say I had something like 4x y cubed over x squared y times y over 8x. And I want to factor top and bottom and cancel. Well, these aren't like trinomials that I can normally factor. So if you want to on these ones, shove it all together into one line. So looking just at your top, I've got 4x y to the 4th. And on my bottom, I have 8x cubed y. And then you can do some canceling. So 4 over 8 is 1/2. X over x cubed, there's 2 extras in the bottom. So I'll leave my 2 extras in the bottom. And then y to the 4th over y, there's 3 extras on top. So I will leave those 3 extras on the top. And that's it. Let's look at another one. Our next one, we've got 2x squared minus 10 over x plus 1 times the quantity x plus 2 over 3x squared minus 15. So same thing, we're going to factor top and bottom. On 2x squared minus 10, I can factor out a 2. The bottom was already factored, and the top on this one was also already factored. The bottom of this guy, I can factor out a 3, and I'm left with x squared minus 5. And then we can see we have this x squared minus 5 on top and bottom that can cancel. So I'm left with 2x plus 2 and 3x plus 1, or 3 times the quantity x plus 1. Let's do another one. So say we had x squared minus x minus 6 on the top, 4x cubed on the bottom, times x plus 1 over x squared plus 5x plus 6. On this one, we've got some factors to do on this trinomial on the top and this trinomial on the bottom, and it looks like our denominator of the first fraction and our numerator of the second fraction are already simplified. So for this guy, we're going to do factors of 6 that add to -1. So that should be a -3 and a +2. And on this one, factors of 6 that add to 5. So we'll have to do a +2 and a +3. So we can see we've got this x plus 2 on top and bottom that'll cancel. And I'm left with x minus 3, x plus 1 over 4x cubed times x plus 3. Let's just do one more. And call it a day. So we'll have x cubed plus 5x squared minus x minus 5 over x squared minus 25 times x plus 1 over 1. So this one on the numerator, we've got something that we're going to have to factor by grouping. So when we do this one, it'll be a little bit different. And then this guy is already simplified, x plus 1 over 1. So we're looking to find a mini GCF here and here. So what comes out of x cubed plus 5x squared, we can pull out an x squared, and we're left with an x plus 5. And what comes out of negative x minus 5 is I can pull out a -1. and I'm left with an x plus 5. On the bottom, that's difference of squares, or you can think of there as being 0 x's. So we would need factors of 25 that add to 0 would be positive 5 and negative 5. Don't make the mistake of trying to cancel right now. The top is not factored yet. You can only start to cancel when the both top and bottom are fully factored. And if there's pluses and minuses like there are outside of parentheses, then you're not factored yet. So I still need to write this as x squared minus 1 times x plus 5, that was in common, over x plus 5, x minus 5, times x plus 1. I'll just throw that on the top here. Now I can cancel my x plus 5s, and I'm left with my final answer, x squared minus 1, x plus 1, over x minus 5. All right, we'll call it a day on these notes. I hope those help. I will see you guys next time.